Well, you knew that we wouldn't be able to leave this section without working on a complex fraction. So let's take a look at a complex fraction when there's stuff that's being added or subtracted. I just love this problem. Look at how neat it looks. We're going to take what looks relatively complex and we're going to make it simple. This bar right here, I want to remind you, doesn't mean anything other than just divided by. That's all it means. So let's rewrite this guy in a way that makes it look more intuitive. What we're really saying is just 1 divided by whatever all this stuff is. Okay, 1 over x plus 3 minus 1 over x minus 5. Now, but we won't deal with the 1 divided by for a second. Let's combine these so that they're just one straightforward fraction. So the way we'll do that is we'll get a common denominator. And in this case, there's no reason to do all that fancy backward shopping stuff. All we got to do is make the denominators look the same. And to make the denominators look the same, all I got to do is multiply this x plus 3 down here. I'll go ahead and write it. We just take the 1 over x plus 3. And to make it look the same as this one, we'll just multiply times, let's go ahead and put in x minus 5. Now if we do that, we have to multiply the top times x minus 5 also, so don't forget that. And then we'll go ahead and we'll subtract. And to make this guy in the denominator look like this one, we'll write our 1. And we'll have our x minus 5. I'll write it off to the right this time. And then we just multiply it times x plus 3. So in this situation, it's way simpler to get the common denominator. But again, we have to multiply the top times x plus 3. Now that we've done that, we can go ahead and finish this guy up. So I'm going to go ahead and by the way, one of the reasons I like telling you about this problem is because there's one that's very similar to this in the SAT practice problems. So let's go ahead and clean this up. We're now going to have x minus 5 minus x plus 3. That'll be in the numerator. And in the denominator, we go ahead and we have our common denominator. I'm just going to write LCD for now. I'm a little bit lazy. And then I'm going to clean up the top. And when I do, we get x minus x, so that's 0. And then negative 5 minus 3. Don't forget to distribute the negative sign. Negative 5 minus 3, that's negative 8. So it'll be negative 8 all over x plus 3 times x minus 5. So that cleaned up quite nicely. And now we can get back to the idea that we're still doing 1 divided by all that. So we'll go ahead and we'll put that back there, 1 divided by. Now, we said earlier that when we're dividing by a fraction, we can just change that around. And so we'll rewrite it as 1 times x plus 3 all over, times x minus 5 all over negative 8. And since it's just 1 times all that, we're pretty much done. If we wanted to clean it up a little bit and make it pretty, we could take that negative sign out in front and leave it as x plus 3 times x plus 5 all over regular 8. We just took that negative sign from that 8 out in front. And again, if this guy was a function, if it was f of x, and we wanted to graph, we would say, in this case, the domain actually is all real numbers. It is not, there is no restrictions. There's no value of x that makes the denominator 0, so we don't have to put in any restrictions. But you still need to know how to graph something like this. This is just a regular old polynomial. Another way we could write it is like this. And it would be really great if you knew at least where the roots were, or the x-intercepts, for a polynomial that looks like this. And again, you don't have to take my word for it that this and this are the same thing. Punch them both into Desmos and look at the graphs and you'll see they're exactly the same. Alright, so that is adding and subtracting with a complex fraction. Hopefully you thought it wasn't too terrible.